I usually start my talks, my technical talks, by telling you there's a lot of code. The code isn't important, that the ideas are. But yesterday, a speaker said something towards the end of the day that gave me pause. How much longer am I going to do this? And it made me change the whole beginning of this talk. I thought back to when I first got married. My wife and I went to a financial planner, and he asked us how long we were going to work. And she said immediately, oh, he'll work till he's 70. And I want to tell you that what keeps me working isn't that I'm not quite 70 yet, getting close, but not quite. It's something another speaker said yesterday, and that was it's important to keep learning new things. And I love that in this ecosystem, surrounded by people that I just love and learn from, every year, every month, every day, I learn new things, and then I love to come and share it with you. So I'm going to talk to you about foundation models. So a lot of speakers have introduced themselves. I never do. But I do want to take a moment to say that fundamentally, and it's right there on my bio, I'm a storyteller. And I tell stories with presentations, with books, with code. And so when I say the code isn't important, the ideas are, I mean that, but the code is important. It's one way that I express my ideas. It's one way I tell my stories. So the code is important, but the code is not the thing that I want you to walk away with. And so even though it's the hot thing, even though other speakers will tell you if you're not using it, you're just behind, I'm not going to use AI to write my presentations. I'm not going to let it write my books. And I'm not going to let it write my code. So, how much longer am I going to do this? As long as you let me. So let's talk about foundation models. Foundation models is how we connect to Apple Intelligence. And yes, I understand the irony of just going off on AI and then saying this. The first thing we have to do is check that Apple Intelligence is available. And we do that like this. We ask the system language model, the singleton in fact, for availability. And then we look at that availability, it's an enum, and we determine if it's not available, what's the reason. So we switch on that available, and hopefully it is available. But if it isn't, there are 3 reasons that Apple Intelligence may not be available on your machine. One reason is, well, you didn't turn it on. Happens. Users don't know it. And also, they don't know when they're using your app that your app uses Apple Intelligence, so something isn't working. They need to be reminded that you need to enable this Apple Intelligence thing. Maybe they have a device that it doesn't work on. That's something we can't do anything about. And then the third thing is, they've installed it, their device can do it, but it's still installing, it's still doing what it needs to do, it's just not ready yet. So let's assume that we've done that check, and let's suppose for the rest of this talk that Apple Intelligence is available. And even though we'll be doing apps here, I'm for the most part eliminating the Swift UI code and just focusing on the stuff that I want to focus on. So the minimum requirements for Apple Intelligence is we need a language model session, we need a prompt, and then we ask the session to respond to the prompt. That's the fundamentals of working with foundation models. So let's import foundation models. Let's create a session and assume there's some world in which I'm doing this that this will compile and run. And we create a prompt, describe a pretty sky, today, not yesterday. And then we ask our session to respond to the prompt. Now, that might take a while, so we await it. Means we have to be in a context that understands this, so I'll put it into a task. It could fail. So we try, and then we get our response, and we display our response. And it might look something like this. We run it, we tap our button, we wait for it to respond. It takes its own sweet time, apparently. Really? Oh, was it? Oh, I'm not seeing it here. I'll have to look at what you're looking at. There's my 3 dots. It's thinking. Okay. Whew. Still not on my screen. So this is a description of a pretty sky that we got back from foundational models, and pretty good, pretty lightweight. It runs on the device, and that means there's limitations. And so Apple is very explicit about this. It is not designed for world knowledge. It's not designed for advanced reasoning. Foundation models is really good for some things. It's optimized for use cases like summarization, although if you get a news feed, you wouldn't know it from there, from extraction, and from classification. So it runs on device, and that means there are limitations, and that means you need to experiment. This is an art. You're going to need to say, okay, if I try this prompt, if I set it up this way, what kinds of responses do I get? And so you need to play, and Apple has given us a new environment in which to do so. It is a playground. Now, a playground does for Swift what a preview does for Swift UI. And so in Swift UI, you add another text inside your VStack, and you see it in the preview. In the playground, as you experiment with the prompt, you'll see different responses. And so we get there by taking our code, and we import playgrounds, and then we use #playground to represent all the, or to surround all this in a closure. And if we're in this closure, it turns out that this is an async context, so I don't need to put this inside of a task. And if I don't need to put this inside of a task, that cleans it up a little bit. And I don't need to display the response, because when I run this in a playground, the response appears in a canvas the same way you see a preview for Swift UI. And this was one of my favorite things that was announced this year. It makes teaching, it makes experimenting with code, algorithms, doesn't have to be async stuff. It makes it really nice to do. You can do it in any Swift file in your project. And so this is a nice tool. So what have we done? We've checked availability, we created a language model session, we created a prompt, and we used the prompt to get a response from the session. Now, a prompt, I think of as being what the user enters. It's what the user chooses. In addition to a prompt, there are instructions. And the instructions are what you do to carve out this area in which it's going to execute this prompt. And what's in the instructions takes priority over the prompt. And the instructions belong to the session, not to the respond to. And so here I have my session and my prompt to describe a pretty sky and my response that says respond to the prompt. And I'm going to wrap this inside of a function. And the function is going to return a string that I can use inside of my Swift UI that I'm not showing you. And so I'll return that response. Response isn't a string. So I need to reach inside the response and get the response's content. Okay? So there's my session. There's my prompt. There's my response. Let's create instructions. And my instructions might be answer using a limerick. You know, there once was a... So once I create my instructions, answer using a limerick, my instructions belong to the session. And so that's where I place the instructions. Notice the prompt goes where I respond, and the instructions go with the session. And now, let's run this with a limerick. It's thinking. There's a limerick. If you read the limerick, it's not much of a limerick, but it kind of looks like one. We'll accept it as a limerick. Now, you can make multiple queries with the same instructions, so I could say, write another one about this morning at Pragma, and it would do its best. Unfortunately, this thing runs on device, and one of its limitations is we only have so many tokens available for prompts, instructions, and responses. And tokens are not even whole words. You can think of tokens as like approximately 2-3 letters. So we have this thing called generation options that we can use to tweak the token use. For example, I can just limit the number of tokens in the response. And so here are my instructions, and I'm going to change it to answer using academic prose, because that would be long and wordy and not just be 5 lines. And so limiting the tokens will be more instructive. And so let's pass those instructions into the model. And in my response, I have my prompt there, but I can also specify my generation options. And I'm going to say, don't use any more than 20 tokens to respond. That's all I want to listen to. And I place that here. When I ask for my response, I say, respond to my prompt using these options. Don't give me more than 20 tokens. And so let's run that. So I'm setting the number of tokens. And that's the response I get. And you go, soft pastels of what? It just stopped. And that's right. We told it you can use 20 tokens, and as it generates, you can actually see that's how it generates, a little bit at a time. And when it ran out of steam, it went, I'm union, that's lunch. So, if we're running out of tokens, we can summarize our session and continue. I leave that as an exercise. It also turns out that we can say other things about the tokens being used for the response, because what happens is we give a prompt, we have instructions, and the model scores the available tokens and says, these are the most likely ones to be helpful to you. And so it scores it. The caution I give, and the reason I say I'm just not going to vibe my presentations, is LLMs always give an answer. You ask it for something, it gives an answer. They never say, I don't know. Man, I would give anything for one that said, yeah, that's beyond me right now. They don't say even, I'm only 40% sure that I'm right, because then we could say, okay, I'm not going to put much credence into it. But we can specify the strategy being used in the sampling to get our response. And so one of the choices is called greedy. And the sampling of greedy tells it how it should select from those tokens. Easier to understand is for a random response, it responds, remember, saying these are more likely to be helpful than these, and so we can use top to say how deep you should dive into those tokens before you use them. The smaller the number, the less you're diving to the ones that are specious, but you don't want to go too small or there isn't enough for us to choose from to get a good response. So just like with prompts, you have to experiment, and you'll get a feel for this, and it's pretty fun. And so you specify your sampling uses random, and maybe your depth is 100. There's some other choices. Another choice is to use a probability threshold. And so there's a cumulative probability. You're ranking these from top to bottom, and it's sort of adding up saying, well, this is 12%, and so it adds them up, and that tells you how deep to go. And so you can set a probability threshold. And the last thing which people do, which is probably the most intuitive, is you can set a temperature between 0 and 1. And what happens is the lower the number you choose, the more accurate and literal the answer is, and the higher it's more creative. So for instance, if I set the temperature to be 87, I'm pretty high up on that scale. And so let's set it to be 0. Let's set it to be all the way at the bottom. And let's run our prompt. And I'm describing a pretty sky, and I'm getting, imagine a vast expanse of the sky stretching endlessly above you. If instead I do 1, and I run this, I'm getting something more like, the sky is painted with hues of soft pink and gentle lavender. Wispy clouds drift lazily by. At some point, I'll point to the sample code. The dice are there. It says picks a random adjective and a random noun, and it puts them together, and it lets you play with those. And then I have the top dice is simple prose, limerick, different forms for it. So it's just something to play with. Now, I'm getting tired of waiting for a response. And I think of it like the way different people use messages. And so sometimes you message with someone and you send them a message and you see this for like 10 minutes. And then you get this like huge block of text all at once. And then there's other people you message and they send you their first thought, followed by their second thought, followed by their third. Like they're sending you little tiny ones. And so in a way, this is more satisfying, except you don't know when they're done. You're afraid to respond there. And so our analogy for our foundation models is to use streaming. So instead of waiting till it's generated its entire response, we say, can you show me what you're thinking along the way? It would help me. And so we wrap our response in a generable type. Now you're going to see generable several times. This is, in a way, the least interesting. I'm not using it the way I'll use it later, which is to take prose and to turn it into a specific Swift type. I'm using generable to say, give me a little bit at a time. So I'm not using generable the way I will. What I'm using it for is to say, take this string, wrap it in a type that I'll call story, import foundation models, and label this as @generable. And this macro allows me to create a stream that updates the story as it fills out. In other words, having a generable story allows me to look at the story as it is partially generated. And so partially generated will be a stream, and it doesn't just send me a little at a time, it sends me a little, and then the next, so it's sending me all of it so far at each point. It's not sending me the first two characters, then the next two. It's the first two, then the first four, as it goes on. So I'll do something like this. I'll have my instructions, my session, my prompt as we've had before, and I'll have a new type, story, which is partially generated, and I'll make it optional because if nothing ever comes, it's nil. It would be nice for SwiftUI not to display anything until it's there. And so the way I create my story is I ask a session for a prompt as before, but instead of saying respond to this prompt, I say stream the response to this prompt. Ooh. And so I get a stream. And I have to tell it what it's building up, and so that's what this is for. I say that what you're building up is a story. And so it knows that it's generating a story, but the variable story is holding a partially generated, so I can say, oh, I'm getting this a piece at a time. This is pretty good. And so since story is generable, the stream is an async sequence. So I will for await, and it could fail, so I for try await. And I take my partial story in the stream, and that's this thing that's being built up over time. And as I get more and more of it, I'll assign it to my story, which is this partially generated story type. And so now it looks like this. Isn't that cool? I think Apple's done a really nice job with the API, but I want to show you a cooler use of generable. Would you like to see a cooler use of generable? Yes. Good. Otherwise, I'd wrap things up. So, here's a cooler use of generable. Who says code can't be funny? We can use generable to extract Swift types from a response. So the response is this prose, this response is this unformatted string stuff, and so suppose we want to turn it into a Swift type. Like, this is even better than codable. So, suppose we want to recommend books in various genres. And so I say, look, I have an enum, and I want a mystery or fantasy or sci-fi or action. And you say, wait a minute, Daniel, didn't they tell you? And it's true. It's just an example. Don't do this at home. Because sometimes I ask for a mystery book recommendation, and it just makes them up. And you know how I know that they make them up? Because they say, this book is by John Detective, or Amy Murderer. So, as an example of generable, we'll be okay. So suppose I want to recommend books in these various genres. I have instructions, and so far my instructions have been very simple. Prose, limerick, instructions can be way more detailed, and I want to show you an example of that. And so let's give example of bookseller instructions, and I say, hey, you're a friendly bookseller, and a customer approaches you and asks you to recommend a book. And you say, well, what genre do you like? And then you suggest 3 books for that genre. Isn't this cool? We're being very specific. We're saying, here's the role that you're playing in this game. And I say, well, for each book, I want you to list the title, the author, I want you to summarize the book, and you should also provide a reason why you're recommending this book in the first place. And so notice these 4 things that kind of stand out. I want you to tell me a title, an author, provide a summary, and a reason. And that tells me the book type that I'm going to go ahead and specify. I'm going to create a struct called book, and it will have those basic types in it. And it will be generable. And this is the use of general that's pretty cool because it's going to take this unformatted string and it's going to pull out the information that seems to match. And what's going to make that work is our foundation model. So I've got my author, title, summary, and review. A generable type must consist of basics like string and number types and bools and things like that, and it consists of other generable types. And story, remember, was generable, so we can use it as one of our types here. And although this isn't going to be very helpful, you can also provide guides to say, here's what you're looking for. Now, if I'm looking for author, having the guide be author of the book isn't very helpful, but there are times that you can be descriptive in that guide and help it pick things out of the prose that it's going to use. So that's a single book. I'm actually going to create multiple books because I asked for recommendations for 3 books, and so I'm going to create another general type called books, and I'm allowed to do an array of a generable type is also generable. So I'm in good shape here, and now I can create a stream as before, and I can say, hey, suggest some genre of books where I've picked mystery, sci-fi, one of these. And instead of streaming story, now I'm streaming books. They're partially generated, and so I'm generating books.self, and in my async sequence, I'm pulling out the partial books, and I'm building them up. And now here's the payoff. Here's my Swift2I code-ish. In my GUI, as I display the books as they come down, as they're partially generated, I'm going to display them. Now, in the example I'm going to show you, I've also formatted things and made it look nice on the screen, and I'm not showing you all those modifiers because they have nothing to do with what we're teaching. But here's the payoff. I can ask the book for its title. This is an actual Swift type. And so it's not guessing. And so I can format the title at the top and the author. And the book.summary was of type story, so I have to reach inside of it to get the content. And so these are all Swift types. And now I can run the same thing and now format these things as they come back because I have Swift types. And it's still streaming, and I'm pretty happy. So. Isn't this delightful? And you guys wanted me to retire before I learned this? Shame on you. Okay, I want to show you one more use of generable, and this is pretty stunning. Instead of looking for books, let's look for a place. And so my instructions now are, you're a friendly travel author, and a customer approaches you and asks you to recommend places to visit in a particular city of a specified type. I'd like to find gelato places in Bologna. That's what they're going to say to you, okay? So the result, this looks a lot like book. The result is I'm going to return names and addresses. That's the result. And so I have a generable type that returns names and addresses. And you say, we've done this, Daniel. I know. And I want a plural of this. I want to get multiple results, and so I take my general type and I put it in there. There's nothing new yet. Here's the new part. I'm going to create and use a tool. Because you have things on your Mac, you have things on your iPhone that know how to do stuff that foundation models doesn't know. For instance, you have maps, and maps uses MapKit. And so I can build a location tool that uses not only foundation models, but it uses MapKit. Now, a tool needs to have a description, so it can say this is what this tool does, and it needs to have a method called call. And call is async, it throws, and it returns some prompt representable. This is mind-blowing. We're going to use Generable this time to take what the user types in and says, or says to you and says, I'd like to find gelato in Bologna, and it's going to turn it into something I can use in a prompt. It's going to turn it into structured code, because then I can pass that information onto MapKit and use it there, and MapKit's going to give me back some things, and I use the other Generable to turn it into the name and the city. So I'm using Generable on the way in here, and on the way out like we did in the last example. And I do that by passing arguments to call. And so inside of here, I'm not going to show you the MapKit code, but here's essentially what it does. I get a map item from the city. That returns something if it goes wrong. But if it goes right, I keep going, and I find all of the things that fit the search in that city. So it's the arguments.search in the map item I just returned, gelato in Bologna, and I return the location search results. That's like my book from before. This is on the way out, derived somehow. Okay, so those details don't matter. What matters is this. I'm going to pull out the city and the thing I'm searching for from the arguments. And so here's the other use of generable. If I want the city in the search, I have to define a type that is generable of type arguments. And in this case, it includes a city and a search. And so when I give it the prompt, find gelato in Bologna, Italy, it says, Bologna, Italy is a city. Gelato is the thing I'm searching for. And now I can fill in these things, and now it knows how to do its search after using the hard tool to figure out the map information. And so now I can use our location tool, and I go back to my session, and I have my language model session, and notice some things go with the session, some things go with my response. The tool goes in here because I'm saying use this tool with those instructions to find the answer to that prompt, generating location search results. And I run it, and it searches the best it can. It doesn't have world knowledge. And it starts finding gelato places in Bologna, Italy. And the lesson here is, it didn't take us much. And of course, gelato is always a good place to stop. So thank you.
All right. Thank you, Daniel. We probably have questions. I cannot imagine we wouldn't have any questions. First question from Arkadiusz.
I'm shocked.
Hello.
Hi.
So my question is rather simple, but I couldn't find an answer in the documentation. Is there any way, I know it can be funny if we are talking about Apple stuff, but is it possible to get any information about our current context window and the token usage, or we have to calculate it by ourselves, just so we don't go over the board with it?
So as you're running out, as you're getting to limits, they do, and that's what I said I left as it's in their deep dive into video from this year. They talk about how you can summarize when you're running short of tokens. I don't know that you can get the actual count. So I don't know the technical answer to yours, but I know that as you're making subsequent requests of the same instructions, and you summarize your history to compress it, but I don't think you get an actual number.
Oh, okay, I understand. Thank you.
Sure. By the way, if someone knows differently, please call out.
Next question.
Hi, thank you so much for the talk. I am curious if it's possible to use Apple's private net.
Wait,
private
you stop right there. Stop right there. Right?
Yeah.
You know the answer to that. He just said, "Can I use Apple's private?" And I'm not going to let him go on
No.
because
Maybe there is a tool like to connect Apple private compute networks so that has like more knowledge but still private. I got it. Thank you.
So I
I
hope
thought you would. Sometimes it takes a minute.
I'm learning fast.
I hope the smile was on camera because it was the answer. All right, next questions.
You're the best teacher. Thank you.
All right, in the back, I'm coming. This room is very big.
Massive.
Hi, thank you for the talk. And I was wondering if is it possible to use some other LLMs with this kind of APIs. So have the responses from other LLMs, but with the same API that we use to with Apple Intelligence.
So, not yet. My guess is what Apple usually does is they use stuff themselves and they release it to us, which I think is good. They beat up on it for a year before they release it to us. I'm not writing a book on foundation models because I'm expecting we'll see a lot more this June at DubDub and probably the DubDub after, but I think it's just early days. They've just given us this, and I really think they've done a nice job with what they've exposed, and I expect to see more. And you can see it in their own tools where, you know, in Xcode you can swap in other LLMs.
Yes.
They traditionally do that. They use something themselves and then they expose it. But by looking at what they're using, we can often predict what's coming for us.
Okay, thank you.
All right, we still have time for one more question. There's another one. Looking in the room, looking left, right. Yeah, over there.
Do you know the thing, I had the right to remain silent, but I didn't have the ability?
Hello, Daniel. Thanks for the presentation. I just have a question about to handle the empty result. For example, if there were no gelato in Bologna, how to handle the nullable result?
Well, first of all, I would be so sad.
Me too.
But so you notice that I left it as an optional, and so if I don't get, that's up to you to respond. But you know, you need to have in your UI that nothing was found, but that's on you to do.
All right. Well, before we give him a round of applause, you already mentioned a little bit your age. And I want to remember that you were born 1 year before Lisp.
Lisp. I'm older than Lisp.
You're older than Lisp. That's set up the scale. Give him a round of applause. Thanks, Daniel.